It ain't good.
All right. So we are going to do the Power Lab today. And to do the Power Lab, you need to have a calculator and a piece of paper. And a full sheet of paper, half sheet of paper, doesn't matter. A full sheet of paper is fine. Because I'm actually going to have you like kind of type up some of the final results. And yeah, so in a couple minutes, and let me check and see. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18. Perfect. So this is going to end up being kind of a partner lab. You're both going to end up doing the activity, but you'll kind of work with a partner, and there's an even number of you, so it won't matter to me so much who your partner is. I'm just particular, as always, about your mask being in place, right? Especially because you're going to be closer than normal to other people, okay? So you need to make sure your mask is always covering your nose and your mouth. But before we even get to that, we're going to kind of get started a little bit with figuring out how many newtons you are. So what you're going to do on your piece of paper, and I would put your name on your paper just in case, because you may show it to some other people or it might get passed around, and so you know that it's your paper. I want you to write down your weight or your best guess in pounds. Your weight or your best guess in pounds. I am not sharing my real weight, but I'm going to do a weight that will be kind of probably in the middle of most of your weight, so you can kind of get an idea as you do these calculations if you're doing them correctly. Okay. So everybody have their weight written down? All right. Now, what we need to do, because eventually we're going to talk about doing power, right? And so we need to figure out what your weight is as a force. So you're going to change your weight to a force. To do this, you're going to take your mass, okay, and you're going to divide it by 2.2. So you're going to take your weight and divide it by 2.2 pounds, okay, to get how many kilograms you are. And let's use at least 4 numbers for that, okay? So just so that you have an idea, hopefully you're not using 150 pounds unless that's really what you weigh. For 150 pounds, it's 68.18 kilograms. So if you're way more than that, your number should be larger, right? And if you weigh less than that, your number should be smaller. And this is because 2.2 pounds is the same as a kilogram. That's why we're dividing it. So again, you need to have a calculator, and we don't want to be passing calculators. So if you need a calculator, there's calculators up here. Okay. Now, we want a force. Is kilogram a unit that we use for force? What do we usually measure forces in?
Wait, how many newtons?
Newtons. So we need to change our kilogram into newtons. And to do that, we're going to multiply our weight by our acceleration due to gravity, our 10. So 681.8. And now the unit is going to be a newton. So this is your force in newtons. And again, if you weigh more than that, it should be a larger number. If you weigh less than that, it should be a smaller number, right? So just to kind of make sure you're doing your math correctly. So I want you to think about this before you say anything out loud. Why don't we measure our weight in newtons?
Look a lot heavier.
Yeah, I mean, look at the number on your paper. Would you want to say that's your weight?
No.
Madison doesn't mind too much. She's like a featherweight. Okay. Right, most of us come kind of look at that number and go, yeah, I don't want to have to say that that's my weight. Although the advantage if we did is everybody's weight would be equivalently large, right? Okay. So it might make you feel kind of bad though, because it's a pretty big number. All right, so the lab that we're actually going to do is power, and you are going to have a partner, but you're both going to do this. We'll see how well my knee is going to let me do this tonight to demonstrate. So what you're going to do is you're going to determine your power by stepping up onto the seat of your desk. Okay? So you're going to step up. You have to stand all the way up, and then you're going to go back down. And then you're going to step back up, all the way up, and go back down. Okay? And you and your partner are both going to do this. Okay? So that's what you're going to be doing. Okay? So, you don't have to stay because you're not going to be. So, for the next little while we do this, would you take a moment? And again, you don't need your Chromebooks, so put them down so they don't get broken. Put them away so they don't get broken, right? Find your partner. There are 18 of you, so there should be 9 groups, and you can sit next to or right in front of or right behind your partner. Oh. And again, if you move a desk, that's okay, but try to remember where the desk goes when you're done. If you don't have a partner yet, stand up, please, so that the other people who don't have a partner can find you. Okay, so it looks like the 2 of you are partners. Maybe you guys want to go over there. There's more room over there. So you need to go sit by your partner.
It'd be better if she can come over here though.
Yes, because there's more space. Yeah. For doing this. Are we doing okay? Everybody know who their partner is? All right. So I want you to make just a little prediction right now that you're going to write on your paper. First off, write a sentence that says, my partner is, and your partner's name. My partner is, and your partner's name. My partner is, and your partner's name. Because you should definitely know the first name of your partner. All right, are we good? So now it's your chance to size people up. You need to decide based on your own, so it doesn't have to agree with your partner, but who's the more powerful person in your group? So you're going to write the more powerful person is, and you're going to write who that is. Again, you're going to decide for yourself. You don't necessarily have to agree with your partner. The more powerful person is, and write that down. All right, are we okay? So right now on your paper, you should have your mass in newtons, right? The force that you are. You should have who your partner is, and you should have a sentence saying who you think the more powerful person is. Would you point at who you think the most powerful person is right now?
Oh wait, in the whole room?
No, in your group. Who's the more powerful person? If you have to point at yourself, you can point at yourself.
Women usually have more power.
Who'd you guys decide? You know it? All right.
Are you sure, Tony?
Okay.
Yeah, that's sad.
Are we ready? All right. So I showed you how we're going to be doing the work, right? We're going to step up onto the desk. Okay. Both of you are going to do that. It doesn't matter who goes first and who goes second. Okay. You're going to step up and down onto the seat of the desk. Both feet need to be on the desk seat, and you must stand up all the way straight. So there's also going to be a timer. So each person And you're gonna probably use your cell phones for that, okay? Each group needs a meter stick and you need a timer, okay? So decide who, or if you each want to use your own cell phone because you know how to do that better, we text one back to that. So make sure you know how to run your timer. Stop cheating, Antonio.
The only thing I have that's alcohol-wise is like labor.
Don't fall down, that's the trick. Let's not have any accidents. All right. So, okay. So both feet need to be on the desk seat and you must stand up straight. The timer is going to be whomever's not currently stepping, okay? And you're going to time this for 10 times. So you're not just going to do this one step, right? You're going to do this a total of 10 times. So listen carefully so you know when you're supposed to start and stop the timer, okay? The timer will begin the stopwatch as the person who's stepping begins to step up. So as soon as they start to lift their foot to step, you should start the timer. And you're going to stop it the 10th time the power person steps up and stands all the way up. Okay? Now my suggestion would be that you both count how many times you step, so there's not a mistake. Okay? So, why are we doing this 10 times instead of just one time? Okay, a better estimate maybe. Because you might slow down a little bit as you're going, okay? Okay, yeah, it would seem like maybe that's the case, that's not so much why, but yeah. How much time do you think it would take you to step up just once? Would it be even very easy to measure that? But it's 10 times going to take you a little bit longer so that you have a chance to start the stopwatch and end that stopwatch. Yeah. Right? So you're going to probably have a little bit more accurate information. Plus, there is the fatigue, right? The fact that you're probably going to get a little bit more tired or winded, right? Stepping up and stepping down than if you just did it once. All right. How are we going to use this data to calculate power? So we're going to collect the data in a couple minutes. I'm going to walk you through the steps. Okay. So what is the equation for power? That was your question today, right? What's the equation for power? Okay. So do you know now why you have a timer? All right. To use this equation, what unit does work need to be in? A joule. Okay. And what unit does time need to be in? Seconds. So it's going to be really important that you record your time in seconds. Okay? Now, what's the unit of power going to be then if it's a joule per second? A watt, right? So this is going to end up being in watts. So when you start to do your calculations, make sure you have the correct units on your numbers. What is the equation for work? There's not time in it. I'll give you a hint. It's the reason you have the other instrument I gave you. There's some distance in it.
I gotta do that try.
What's this is a force, right?
Oh, force times distance.
What unit does our force have to be in? What are you lifting up and lowering? Your body, right? That's why we started with your weight. What does distance need to be in? Meters. So you have a meter stick, right? But if you measure something to be, let's say, and we're going to have to measure this, but let's say you measure 23.2 centimeters. That's not a meter, right? How do I change that to meters? Is a meter bigger or smaller? Bigger. So should I move my decimal left or right? Left. Anybody know how many places? 2. So this would be 0.232 meters, right? Most of you are probably going to use your meter stick to measure centimeters, but you need to report it in meters. Now, what are you going to measure? Yeah, how high off of the ground the seat is. And don't do it quite yet, but that's what you're going to have to measure, right? So your distance you're going to measure is going to be the distance from the floor to the seat. And then I don't just do that once though, right? How many times am I doing that? So what am I going to have to do to this? Right, my total distance I'm going to have to multiply by 10. So in this example, it would be 2.32 meters total that I stepped. Okay? And again, you're going to do yours specifically, but I'm kind of walking through this example I've given you. I don't think this is what you're going to measure your height to be, but imagine if I had measured my height as this. Okay? This is what you would do with them. All right. What unit then is my work going to be in? A Newton meter. What's a Newton meter? What's another unit for a Newton meter? A joule. Right? So by having my force in newtons and my distance in meters, I have my work in joules. Remember, that's important because what did we say over here I needed my work to be? In joules. Okay. So some safety concerns. This is not a race. Step carefully so you don't hurt yourself. Be careful to not push the desk away as you step up onto it. It's not too bad because it's carpeting, but a suggestion might be for the timer person to actually like stand with their legs against the desk so that it can't move away from the person that's stepping up accidentally, just to kind of make sure that nothing unfortunate happens. Okay? Does everybody understand what you need to do? So you're gonna measure, and both of you in your group should make sure you agree with the reading, the distance for the meter stick, right? Okay. You're gonna measure that. Then one of you is gonna do your stepping, and the other person times for the 10, and you need to write that down, right? Because let's say, for example, let's say I did this and it took me 15 seconds. So how do I use this information to figure out my work? What's my force?
Up there.
Okay, the 681.8 newtons. What's my distance? The 2.32 meters, right? Because it has to be in meters. So then again, that's why you kind of have calculators or you're using your phone, right? Because this becomes about 1,582 joules, right? And it's a joule now. Now we're calculating power. So now I'm going to come over here, right? What am I going to put in for my work? Yep. What am I going to put in for my time? 15 seconds. Okay, so this is going to be my power. So 1,582 divided by 15 is about 105.5 watts. So once you and your partner both have finished doing the measurements, Then sit down together and each of you do your calculations separately, but just kind of make sure that you're comfortable with your calculations. I'm going to give you, how about till 1 o'clock to see if you can do that. And I'll check with you at 1 o'clock and see if you're done. Okay? Everybody understand? By the way, do I have to measure the seat twice?
No.
No, right? Because the seat height isn't going to change. But make sure you measure, decide what desk you're going to use. Make sure there's space next to it. Okay, so you have room to step up. Okay, so I'll give you and your partner, like I said, till about 1 o'clock to do this.
All right. Are we using that?
Okay, my leg hurts, so.
Oh, you just like poked my eyeball out.
Both people, make sure you write down the distance and such.
No, I'm sorry. It's like 43, like 2. So.
All right. First.
All right.
I guess.
You ready?
So your time is
Go.
up. Yeah,
So.
You guys have
Yeah, 43.
I just wrote down the centimeters. I haven't done anything. I got 4.
I have to stop there.
29.41.
Again, you guys, just write down your data at first. You can do your calculations when both you and your partner have finished taking your measurements.
Oh, yeah, you're right. Am I going? Yeah, just get ready, go. Yeah.
Alright, again, do not do your calculations until both you and your partner have gotten your data collected.
Yours was 26.5.
I don't know where.
Oh, this is no.
Just that since you're taller, it takes a little longer. You take your rest. Yes.
Oh.
I got this.
Okay, I get it now. My bad.
After you've done your calculation, go back to that original thing you said about who was more powerful and decide if you were right.
Yeah, I'm out of breath.
Wait, so.
What was the height of the?
Yeah, 43.
So,
Are we doing all of them?
we were right about you.
Again, help your partner if they're struggling with the calculations. Look at your partner's calculations and make sure you agree that they've done them correctly.
You do your side, and I'll do my side, and then we'll swap them. So you guys, right?
Why do you think that is? How about you guys? Who's the most powerful here? You're not going to. And help your partner if they need some help with the calculations.
I have the, okay,
We need the distance.
yeah, but you never,
1,008.
and meters, you never.
Yeah.
That's what.
You win.
So you do your calculation by.
I don't think it's wonderful, but you win.
Well, no, mine is to go, that's how what I measure my distance to be, so I can use your distance.
Oh,
You guys, you're not gonna use any of the numbers that I have on the board, right? I just gave you an example so you could look at and follow it. You're gonna use your own numbers to calculate this.
That's your.
Yeah, but we moved the dustbin and I'm.
What's wrong?
So, what are you talking about? Do you move the dustbin back to the right?
Right, so what did you measure your clients?
Well, I know you.
42.5, so you made it 0.425, right? And then you multiply it by 10, so then it's gonna be 4.25 mils. Yeah, so that's the right.
Like hers or like?
So then that's what you use. So you use that as your figure out your work. Right, so where's your next?
We're trying to figure out how to make that number.
This is your it's just making to make it Now take that number in your calculator and multiply it by numbers.
Yeah. It's so.
You take that number. Divide it by.
That's your, so write it down, what you did, right, and that's your distance.
Yeah.
Because you did it 10 times, not just once. So.
Alright.
So now that's.
Whoa, he's probably speaking over.
Here's what you're gonna
That's a great idea.
Oh, yeah, it's funny.
So I guess I would.
Did you guys finish up? And was your prediction right? Who did you say? And was it you? How about you guys?
We did some.
Yeah.
You did something wrong?
We got some power.
Or else
So
it
you're
wants
gonna
more
go back and fix it, okay, because you guys were really, really powerful. Well, at least you realize that. They're gonna use you as an engine in a car, that's all.
Yeah. She did that.
You want me to put this back in the,
Oh, yes. You guys see it, right? It's like the most powerful. Is that what you're doing? No. Who is the most powerful? Is that what you guys do?
It is. It's so northern reaching in this world.
All right, is everybody finished doing their calculations? After calculations, if you put the desk kind of back where they go, I prefer you go back to where you normally sit, but if you want to stay by your partner, that's okay too. So you're right. So you're gonna do those numbers together and write it down. What was your work? Yeah. Yep. So write it down. And then you gotta take a seat of power. And you do all your That'd be great, Gabby. Okay. So then, yeah. So then you're gonna take that number and divide it by whatever your time was. You guys, you should probably get something around this number-ish, right? Antonio realized that he was not 10,000 times more powerful than this, so he realized that maybe he did his math wrong. So again, you guys should be around that number, okay? Might be a little higher, you might be a little lower, but right around there, probably about. Might be higher. You still didn't get it?
No, I said I was close.
You were so really close. All set, Logan?
Yeah.
All right. So we're not quite done with the lab. So I need your attention because I'd like to have you have enough time to get this done in class so you don't have homework tonight. Okay? So look at your power. How powerful you were, right? Because that's what you have on your paper in front of you. Is Andrew having a problem?
I'll figure
You
it
got
out.
2.27.
Could you power a 100-watt light bulb?
Yes.
I can power it.
Okay. How do you know whether or not you could?
Because you're putting off 105.5 watts.
Right. As long as you are 100 or more is your power, then you would be able to power a 100-watt light bulb. So by raising your hand, how many of you would be able to power a 100-watt light bulb? Okay. Would you be able to do it for very long?
No,
How do you know that you wouldn't be able to do it for very long?
you have 5 left over.
Yeah, you don't have very much left over, right? So you probably wouldn't be able to do it for very long, but you could. Okay, most of you. All right, so now, one more prediction you're gonna make. Look around the room. Don't talk, just look around the room. I want you to predict, and write it down on your paper, who's the most powerful person in class. Don't say anything, don't share your numbers, okay? Look around the room, and if you need somebody's name because you think they're going to be most powerful and you're not sure what their name is, you can ask them. But who do you think is going to be the most powerful person in the room? And you have to write it down. Now, this is a hypothesis, an educated guess. Why would this be an educated guess? Was the first guess an educated guess? Did you really know anything about it?
No,
No, why is it an educated guess now?
because we know.
Because you calculated your own power, right?
Yeah.
So now you kind of have an idea, and so now you can kind of think about yourself compared to the other people in class and make a better educated guess. Okay. So another little bit of math you're gonna do. So are you ready? Okay. You're gonna change your power in watts to horsepower. And to do that, you're gonna take this number that you got for your power and divide it by 750. So for me, for this example, because I don't weigh 150 pounds, it's 0.1406 horsepower. So take your power number that you have, divide it by 750, and write down what your horsepower is. If I was 150 pounds, I would be a very powerful horsepower. Not a very powerful engine. I know we have some car people in here. What kind of horsepower do little 4-cylinder cars have?
Really varies, I mean, I don't know.
Okay,
I can give you an exact.
roughly.
200-300, probably, maybe around 4. I mean, big blocks are pushing 610 to 810, so.
Okay. 600 horsepower.
Yeah.
Okay.
Yeah.
So a big engine might have 600 horsepower. Okay. How about like, you know what? You might know horsepower on. What about your lawn tractor or your lawnmower? What kind of engine horsepower do those typically have at all?
Like 14 to 25, probably.
I think they're more like smaller than that, but.
That's, all the ones that I've ever had are bigger than that.
Okay.
I've had one 8 horsepower, and it was
Okay.
smaller.
I could probably car a little RC.
All right. So, look at your horsepower number. Anybody more than 0.2 horsepower, put your hand in the air. So you have 0.2 or a bigger number. So only Gavin has 0.2. Oh, Hunter does as well. Okay, so one of those two is the most powerful. What was your number?
0.20352.
What was yours?
1.079.
You sure you did all your math right? Yeah, that seems way off. You probably need to go way back here and check all your math.
There's no way.
You got what? 0.27?
Oh, it's definitely not.
So guess who the most powerful person in the room is?
No.
Mason.
Mason.
Did everybody guess Mason?
Oh, I guess Gavin.
It's the beard.
Why do you think Mason might be the most powerful person? Without being really, what's that?
He's built different.
He's built differently. Okay. So he's maybe a little bit more solid than some of the other people in class? Is that an okay way to say it? Okay. All right. So, did I put this thing in Google Classroom for you? Yes. Okay. And I'll double check that it's there. What I'd like you to do, and if you want to handwrite it out, because what I'd like is these calculations written nice and neatly again. Okay? And then there's 3 questions, right? What was your hypothesis about the most powerful person? Why did you pick that person to be the most powerful? And was your hypothesis correct? And so I'm going to double check that this is in Google Classroom because those questions are there. Yep. So these questions are at the very bottom of the Power Lab paper that's there. So I want, okay, on a clean sheet, write down the data you collected, Show your calculations nice and neat and answer these questions in complete sentences. And the hypothesis we're talking about here is the most powerful one after you have done your measurement. Okay? Which turned out to be Mason. So that's what you need to do. That's what's due Monday. This Power Lab's due Monday, but if you get it done right now, you can turn it in right now. You can do it on a piece of paper, right? Just copy nice and neatly what you have in your calculations, and then answer those 3 questions that are listed there. Does everybody understand what you have to do to the Power Lab to turn it in?
Yeah.
Okay.